3D shapes, but it's still just two-dimensional Pythagorean theorem. So we're still doing a squared plus b squared equals c squared. We just have to know a little bit about it. So if I look at this shape, right, here's my hypotenuse. Here's one leg, and here's one leg. You have to be really aware of what it's asking you. But I can still, because there is a triangle inside of it, this is the height, this is the, what's this called all the way across the base? I mean, of the cylinder, what's this called? Nope. Starts with the letter D, ends with diameter. There you go. So we have a squared plus b squared equals c squared. Where we have the height, we have the diameter, the distance across a circle, and our value. So I could do 8 squared plus 15 squared equals x squared. So 64 plus 225, and then the square root of 64 plus 225. What is it? 17. And then I have this shape, a cone, and there's a right triangle inside of it, correct? So this right triangle, again, it's just a three-dimensional shape, but there is a two-dimensional triangle inside of it. A squared plus b squared equals c squared. I'm given the base plus the height, and I'm finding the diagonal of the cone. How long is the cone from the tip of the ice cream cone to the rim of the ice cream cone, right? If you wanted to measure that distance. What is, you can tell me, 5.7 squared plus 2 squared? Is that my answer? Leg squared plus leg squared equals hypotenuse squared. But then what do I have to do? The square root? Oh, 12. Sorry. I apologize. 12. 5.7 squared plus 12 squared. And then I take the square root of that. So my length from the cone tip of the party hat to the base of the party hat is approximately 13.28. All right, this guy's a little bit more hidden. Where's my triangle? Ooh, Dylan. What'd you say?
7 squared plus 2 squared.
Why is it 2?
Because 7 is going down the middle.
Perfect. 7 is your height right here. But this base is not 4 and is not 5. It's half of that, right? So it's 2. So we have 7 squared plus 2 squared is 53. And the square root of 53 is approximately 7.28. All right, same thing. Here's my triangle. What are my dimensions? 4 squared plus 3 squared because it's half. I don't even have to do my math, you guys. What kind of triangle is this? It's a triple. 3, 4, 5. I do not know that. 3, 4, 5. If your base, your legs, right, are 3 and 4, your hypotenuse is 5. All right, so 3D shapes that involve two-dimensional Pythagorean theorem. Let's talk 3D Pythagorean theorem. There are 2 ways to do this problem. Three D Pythagorean theorem. Sometimes some of the packages I get from Amazon delivered to my house, I think to myself, maybe we should go to a shipping center and work on Pythagorean theorem in 3 dimensions. Because sometimes the things that come in those boxes, yeah, it's a little out of control. Now I get it. Maybe they ran out of the size of box we needed. But this is, if you work in that, you should, if you figured out the 3D Pythagorean theorem, you'd be able to be like, oh, this box will only fit up to this amount. So, if you look over here, we're going to kind of go back and forth. We are finding, and you have to get this kind of visualization. We are not just finding a regular diagonal. We're finding this internal diagonal. So, like, I can find this hypotenuse because there's a triangle on the bottom, correct? But I want to find the hypotenuse from the back top corner to the front opposite corner. I want to find the diagonal inside of the box. So there are a couple ways of doing this. And you have to kind of appreciate this invisible triangle inside. So there are 2 ways of going about it, and we're going to talk about one way is to find the hypotenuse of the base. Find the hypotenuse of the base, which is basically, right, a squared plus b squared and the square root. Do you agree with that? Is that a shorthand way of saying it? Yes. You do leg squared plus leg squared and take the square root of that, and that gives you the hypotenuse, right? And then this answer, this guy right here, becomes a new leg. Is that true? If this is your hypotenuse of your base, right? Even though this doesn't look like a right triangle, it is. So you found the hypotenuse, and now that hypotenuse is a leg for your inside triangle. So once you do a squared plus b squared and the square root of that to find your hypotenuse, the hypotenuse becomes a leg of the diagonal triangle. So you did a squared, the base. Over here, we would do, what is this? What's a? 5 squared plus, what's this? Good, it's over here. 2 squared. And that's going to be my hypotenuse. Is that correct? 5 squared plus 2 squared. 25 plus 4 is 29. The square root of 29. All right, so the unfortunate part is, what do I have to do to this number? I have to round it, so it's going to be approximately 5.39. Do you agree? Is that hypotenuse? 5.39. And now that hypotenuse becomes a leg of the diagonal triangle. So I'm going to do 5.39, yes, squared, plus, and then my height, good, is 4 squared. And I can do the square root of that to find my internal diagonal, correct? So again, I'll do a squared plus b squared, and that will tell me my internal value, correct? So what is 3.9 squared? Nope, that's not it. 5.39 squared plus 16, yes. 4 squared is 16. And then I have to take the square root of that. So the internal diagonal, the biggest pixie stick this box could carry would be what, 6.71 on a diagonal? So the first way of doing this is find the hypotenuse of the base, a squared plus b squared. Then we find the hypotenuse, this answer, becomes a leg of the diagonal. So we'll do a squared plus b squared. But this a squared is the first hypotenuse. And this b squared is most likely the height of the prism, the box. So that's one way of doing it. The downfall, what's the problem with this guy? What did we talk about already? What did I have to do right here to my answer? I had to round. So I'm rounding and then using that rounded number again, so I'm always going to be a little bit off, correct? It's okay, it works. You just say I round, you know. But there's another way. There's a second formula. And some people love this formula because they are this way because they don't have to memorize a new formula. This way is going to work no matter what. You just have to say, acknowledge that you rounded here. And if you show your work, you're good. The second way is there's an actual formula. Now, the downfall is our formula is a little bit different than what we're used to working with. All right, so if we look over here, it's all going to be under the square root because it's Pythagorean Theorem. Do you agree? We're trying to find the diagonal of a rectangle. Not a rectangle, a triangle. All right, so let's look at this guy. So here's my internal diagonal. Do you agree? It's not perfect, but it'll do. And in order to get this internal diagonal, I have to figure out, I know this leg, but I have to figure out this leg. And the only way to figure out this leg on the bottom is to do the Pythagorean theorem of the base, correct? So I'm going to label, because this is a little bit different, I'm going to label this guy X. I'm going to label this guy Y. And I'm going to label this guy Z. So you don't ask if is that a 2. In order to find the base down here, what do you have to do? What variable? What variable? Variable x squared plus y squared, correct? And then do the square root. X squared plus y squared. And do the square root. Do you agree? But hold on. X squared plus y squared and do the square root. And then you take x squared plus y squared and the square root of that. And what do you add to it? Give me a variable. Z what? Z squared. So the formula is x squared plus y squared plus z squared, and the square root of it. Let's test it. Let's go back to that first one and see if we get roughly the same answer. So, on the other one, what would be your x, what would be your y, what would be your z? 2 could be the x.
5 would be the y.
5 could be the y. And 4 would be z. Perfect. Try it out. So we're going to do 2 squared plus 5 squared plus 4 squared. Oops, I have to turn on my calculator. 2 squared plus 5 squared plus 4 squared. Really, in all actuality, could you do it in any order? Because why? Because you're just adding, right? Order of adding does not matter. So 2 squared plus 4 squared plus 5 squared, or 2, 5, 4. And then the square root of 45. We add 6.71. 6.71, it works. All right, so let's try this one. 11 squared plus 7 squared plus 23 squared. Right? X squared plus y squared plus z squared, square root. Or you could always do 11 squared and 7 squared to give you this number, and then this number squared and this to give you this. You could even go as far as to put it all underneath the square root sign already, right? Am I right? Did you get the same answer as me?
Yes.
4, 4. All right, try those last two. But it's basically the same thing. You're just not hitting equal in between your it doesn't matter which way your triangle goes either. And then you just use your calculator. Because you're doing leg squared plus leg squared and using that answer as your new leg. So adding that to your third, right? You're making everything become legs. And we're rounding to hundredths. Always be aware what it asks. Tenths or hundredths.